We're going to start by solving homework 9, number 4. We're going to solve for the homogeneous version. That's our first step. So we're going to set this whole thing equal to 0. We're going to find the annihilator for this, d cubed minus d. And this part right here is my f of d. The characteristic equation is m cubed minus m is 0. We can take an m out of this, set it equal to 0. From there we're going to get m is 0, positive 1, and negative 1. Our FSH is equal to 1 e to the x, e to the negative x. From there we can find my YC is C1 plus C2 e to the x plus C3 e to the negative x. My next step is to solve the non-homogeneous version of this. This right here is equal to my j of x. My g of d is the annihilator for that, which is d minus 1. Next, I'm going to multiply my fd times my g of d. That's going to give me d cubed minus d, d minus 1. Set that equal to 0. My characteristic equation is equal to m cubed minus m times m minus 1. And now I'm going to solve for my m. This is going to give me m is equal to 0, 1, negative 1, and 1. My fs is equal to 1, comma, e to the x, e to the negative x, and x e to the x. From there, my third step, to find yp, we have to take my fs and h minus my fs h. We're going to look for what's in each equation. So the 1's cancel, the e to the x cancels, the e to the negative x cancels. From there I'm left with x e to the x. My next step to find my yp, I'm going to say alpha, since it's the only one in there, times x e to the x. My original equation is this, but I'm going to make it yp. So I have to find the third derivative and the first derivative of this function. We're going to see that these two both cancel, so I'm going to be left with, when I simplify it, 2e to the x alpha is equal to e to the x. So from there we're going to see that alpha is equal to 1/2. Our next step is to go back and plug that in. So I'm going to multiply alpha by my set. For alpha, we got 1/2. Next, I'm going to say y is equal to yc plus yp. Now we just have to go back and plug in what we've already solved for. My yc is c1 plus c2 e to the x plus c3 e to the negative x plus what we just found, our 1/2 x e to the x. where all the c's are arbitrary constants.